My name is Monto. I am basically an architect, and my master's degree is in civil engineering, and my doctoral work is in the area of sustainability. So I'm with the Indian Institute of Science since 2005. Before that, I was with IIT Kharagpur with the Department of Architecture for some time. And I'm at the institute. I'm with the product design group as well as sustainable technologies. So I'll be. It's a mix of talk actually from what Ravi told me. He asked me to talk on manufacturing specifically. I'll be touching partly, and these are some debates that I have been grappling with both in my course as well as in dealing with sustainability when you're connected with design. So, am I audible or it's okay? Okay. So this is the thing. Some questions I have for you as to what do you think is sustainability? Is it lasting forever? Is it 8%, 4%, 1% economic growth? Is it happiness? What is sustainability? And don't ask me, don't look at me. I don't know the answer.
For me, it's an equilibrium with my surrounding, and I don't look for more all the time.
So when you look, not looking for more, I mean, what is that? Is that happiness? Is that contentment? Is that
happiness is challenging. Contentment is a better word.
Okay.
Will never be happy.
Okay. So are you in equilibrium now?
There are moments I do get, but there are always challenges comes. Your definition of need changes as you go along. But as you go and I start seeing my life from a little further away, I think it's ridiculously not required. So many things I do.
Then what do you do about it? What do you do about it? You're aware that it's ridiculously not required.
If I can sustain a certain, the meaning is changing of that energy, and so hence if I'm in equilibrium, I'm not trying to sort of acquire, get.
So where is that equilibrium?
More, fast, more,
Where is that equilibrium?
It is very difficult. It's internal.
You know,
internal
if you look at.
It could come from I reduce my consumption to 5 shirts and 5 pants, and that's it. For somebody that also will be much higher than he may be living with one needs,
So Donald Trump is in equilibrium now.
Maybe. So each one is different.
Okay.
As long as so if my actions, I think any action human does today has a negative impact in my opinion. Any action.
Okay.
As long as you're adding a value, like other animal ecosystem adds a value to the surrounding and a system, they sustain a certain ecology, which is interdependence. We have removed the interdependence. I can do everything from big basket and things. I don't need to walk to
So
my local store.
if I can rephrase that, the apparent interdependence has been taken off, or would you say that the complete interdependence is gone from a systems point of view? No. He said that humans have taken.
I get it now what you said.
Yeah, so I'm saying that is it an apparent interdependence or is it a systemic interdependence?
It is systemic.
Okay,
and
so
apparently we are all dependent, like Facebook thing. Like the interesting thing I read is the Book My Show owner. He stopped his Gmail, his Facebook, and all for 8 years back. Because one of his friends, he had 3,000 Facebook friends. Not a single guy was there in that. So I'm just saying that coming. Apparently, I have 3,000 friends, but there's not even a friend I can call who will come. So I don't know what that means.
Okay, so then I will share something else also with you since
Sure.
this. Okay, what about the others?
One thing is taking a product or a system up to its end of life. Like she told about the shirts. When a new shirt or a new design or something comes up, you naturally want to have that. Your old shirt is good enough to last for another 2 years or 3 years. Or our phones. It gets outdated in no time and it can still work for another so many more years.
Is that so? I mean, will your phone still last you more than 3 years?
Yes, of course.
Will it? Okay. Okay.
I think sustainability is our generations to come, my children, their children's children, are able to live as as much resources that we've had, and with the beauty that surrounds us now. It's fragile, but still there some places. So with the same kind of beauty, they are able to live. In fact, the humankind is able to live and see this earth
then we have an economic right to buy everything. But all living beings have a moral right, equal moral right on resources. And we keep forgetting. Then we put analogies of this human beings, so much.
No, I just, from the point of view of survival of a species, we are a species which should be able to survive. We have our needs and requirements, and unfortunately, one of our needs is to consume. Right? So, even with that need, we should be able to keep planet as it is.
Okay.
No, I heard
That's-
this in another sustainability conference, and the example was of a Buddhist monk and one of his disciples going and asking him, give me new, like the way you said, some new garb to wear that monks wear, right? And he said, and the design itself is interesting, that it's just a one piece and you do what you want with it. It can go whatever kind of size you want. But the monk does not give him immediately. He says, what did you do with the previous one? What you had on it? He says, I made a curtain of it. And then he says, then what did you do with that curtain? And he says, I used it as, to cover my bed or something like that. And then after that, what was the use? And then he says, it was too worn out. I tore it to pieces and I used it to dust and clean and everything as well. And after that, what did you do? It was completely gone. I was able to, kind of scatters as such. I could put it in a lamp and light it. So it kind of got elevated, from there in a certain sense, not just discarded. And so it's like interesting how this sustainability has been part of this understanding, the Buddhist kind of.
Okay, so I'll just take you to what is the role of the designer? And in my view, when you said the humans are the hero of the planet, I would say the hero of heroes are the designers. Am I right? So in one sense, if you look at art or architecture anywhere, it's an indicator of prevalent society or culture, whether they've been prosperous. There is one definition of culture which says that culture happens or traditions are built in once the basic strife for survival is taken care of. The community is not struggling, fighting, and then you have art, music and all start to come up. So that's one definition of culture. Okay. And the role of the designer, I'm asking you, is it meeting customer client specifications, requirements? Is it something that sells well? Obviously looks good, that. And is it empowering? And the question I have here is that what is the designer's role in society? Is it just the responder to certain set of requirements, or is it a responsible facilitator? And I'm going to take some examples to draw this insight, but what is your view?
The designers should responsibly design their products. It's not just
So-
I make something for making.
Yeah, that is as far as so-called environment-friendly material. Can you tell me one environment-friendly material?
Okay, like suppose furniture.
Okay.
I can't just keep on cutting woods and making furniture for my own profit. I have to, like now they have put some rules and regulations that no, I can't just cut woods and keep on making furniture. I have to think about it. It should have some limits. Maybe now as they came up with the alternative plastic and other materials which I used to make furniture.
Okay. Yeah. Any other views?
Like when the elephants were being killed for the ivory, that's not
I mean, they're still being killed, right?
Huh?
They're still being killed to keep their populations in check, and so that.
There are so many species which are completely gone because of human beings.
True. Okay, so this is from a book called The Zero Energy Development. Okay, it's about buildings, and here they're trying to look at satisfaction with life versus ecological footprint. And ecological footprint, are you aware of it? You must be. Okay, it's basically the land masses required to support the resources that your lifestyle depends on. Okay, it's in global hectares per capita. And this is also equivalent to that happiness index and stuff like that, where Bhutan is on the top, and the metrics for satisfaction of life is different. Okay. But here the idea is that, okay, do you have time with friends and families? Are you contented with yourself? Are you happy with what you're doing? And that versus your ecological footprint. And you find that most of the progressive nations are actually very low, but very high satisfaction with life. So there isn't a correlation between either a GDP or economic growth versus satisfaction with life. It's not that just because you're richer, you're producing more, you're likely to be happier. It's not so. Okay, so that is one thing. The second thing is with rising income levels. Because you're designing, you want your products to sell, you want your company to succeed, you want your startup to succeed, but that necessarily doesn't mean happy. Because when you look at competition, you have to be in the competition, and in the competition you're chasing, and when you're chasing, you're not necessarily contented. Okay? So the fact is that from the time industrial revolution has started, mass production has started, people have not necessarily been, or people are not necessarily happy. Okay? And just going to give you different insights. Like I said, it's a mixed. I sat up and based on what Ravi had mentioned, I tried to give different examples from what I have learned or I have been exposed to in the last 10 years. The left hand side is a house in a place called Bikangaon in West Bengal. Sorry, Nayagram in West Bengal. Nayagram in West Bengal. It's close to Kharagpur. And the right is our lab at the institute. It's a photovoltaic roof. Okay, we designed it, we have a patent for it, and we called it green and stuff like that. How many of you think that photovoltaics is green?
Sorry, please.
How many of you think that photovoltaic is green, is environment friendly?
Comparison is
By itself.
Is green.
By itself.
I find the left is more greener.
No, I'm not saying compare it with the left. I'm just saying just photovoltaics by itself. Photovoltaic. PV cell. Solar cell.
What do you mean by green?
Yeah, I'm asking you.
What do you mean by green?
To me, I don't think, I mean, the trees are green,
No.
nothing else is green to me.
You mean you make a life cycle assessment of that?
Yeah, whichever way. You could do a life cycle assessment, you could do a so-called pollution-free related definition of green. You could say that it's not having emissions and that definition of green. So that's the reason why I said everyone calls it green energy, everyone calls it renewable. So I wanted your views on it. That's all I wanted.
By itself, it's not green.
Okay, why so?
Because it is purely inorganic material composition.
Correct.
So by itself, it's not green, but then it facilitates, it supports green systems.
Okay, what are those green systems?
Or renewable energy.
Okay. Okay. Got it. Okay, so
Can I add another example
yeah.
to it? So, like we call electric cars green,
Hmm.
but we don't know, like, I don't think it's green because the power it runs on is electricity, and we don't know how the electricity is generated.
Correct.
It can be generated from coal waste.
But there you only bring in, or yeah, I agree with you completely. Yeah, the pollution is somewhere else, and that's a standard. The whole issue of development is that,
Somewhere else.
you know,
Landfill is somewhere else in village, not? It doesn't have. Landfill is clean and nice.
Would you speak up only about environmental impact or on sustainability in general? Because this is a form of distributed renewable energy.
yes,
Which may have social impacts. So it's,
yes.
I would just wonder.
I'm coming to that. Okay. So if you look at this type of houses, we studied for a year, and when we studied it as an architect, you want to study the design, you want to study the building materials, you want to study how it performs. Okay, and the distinction between zero energy and energy zero. So these are houses which don't have electricity in the first place. So I would call that zero energy. And that lab that we have, we are generating using photovoltaics as much as we generally consume, and we call that energy zero. Okay, but who puts a cap on how much you can consume? You can say that, okay, my house consumes a megawatt, and I put a 3 megawatt solar system, and I say I'm green. So from a moral ground, where does that stand? Because most of your rating systems are efficiency based. Okay, and there are some problems with efficiency as well. And when we said life cycle and closing the loop and cradle to grave and stuff like that, if you look at the entire resource cycle in the house, there's absolutely no concept of waste, and this is known. Okay, what we've done is we only quantified it. Okay, because we found that when we study this house, this thatch roof comes from their crop, and they change it every 5 years. So every 5 years they actually choose seeds which gives them a crop of a particular height. The other 4 years they choose seeds which give them a shorter crop. So we found that the entire agriculture is actually connected with the house as well. And then when the house is getting done, the entire family gets together to chip in. So it's a social integrity that happens. This house has one common family area. So the family has kids, they have one common area. The son gets married, he comes, has his bedroom attached, but the family common area remains the same. Okay, but then those are changing, and if you call these are called kacha houses. These are not developed. In terms of pollution, they don't pollute. In terms of green rating systems, they are way above any green rated building that you can think of today. Okay.
Those person there.
Yeah, the left one.
How they cook stuff.
Firewood. So when I said
This is the most polluting.
no, there is a debate there. They said if you look at New Zealand, Australia, they're promoting firewood because they call it carbon neutral. As it grows, it absorbs carbon. See, I'm not disagreeing with you.
Fumes from
Yes. Now, okay. Now fumes are a problem. Yes. Yes. I agree with that. Now our center, I don't know whether you heard of it. It's called Astraole. We've been designing fuel efficient firewood stoves for the last 30 years. We've disseminated 1.5 million. UN is adopting our stoves. We are talking of efficiencies of 45% and absolutely no indoor pollution. Okay.
Most of them have this.
Yeah, so I'm not saying, I agree with you. I'm not saying that you should not change them or you should change them. I'm just saying, okay, well, what are the consequences? Okay. So this is one cycle, and then what happens is that you measure temperatures. Okay, and you say, okay, this is the external temperature and this is the indoor temperature. Now these are houses that are not air conditioned, and getting this temperature profile maintained is not possible even in this room. I'm talking of a 2-degree modulation, and if you measure your air conditioned room temperature, it would vary from 4 to 6 degrees from the time you feel very cold and the thermostat switches off to the time when it takes off again. Okay. And then what we did is that we looked at the orientation of the building, and orientation of the building is primarily the long axis of the building. This is the definition that we have taken, and we say, okay, the long axis of the building in terms of the building materials you've used and the climatic conditions there, what is the best orientation that you need to have to maximize the passive performance of the house. And this is the orientation that our computer based simulation tells you, and this is the orientation that we actually observed, and this is not an accident. Okay, they've probably done it by trial and error, but definitely there is some know-how here. And if you look at climate change IPCC documents, they clearly say that modern know-how needs to be integrated with traditional knowledge for climate change mitigation measures. Okay. And if you look at end of life, you take off the roof, the soil just goes, there's no pollution, there's no disposal, there's no, nothing of that sort. But this is what is happening. And this is happening in India. Okay. You have first, these guys want to modernize, so the roof changes first. Then the walls change from mud walls to brick in mud mortar, and then it changes to brick in cement mortar. Right. Now, why is this important? This is important because if you take India and China put together, have 1.8 billion people who are changing this way. Okay, and if you have to then provide for this 1.8 billion people and say, okay, I need the resources to support them with electricity, to support them with LED lighting, to support them with houses, where do we have the resources? China is urbanizing in a much faster scale, but India is changing much slower, and 1.8 billion is not a small number. Okay. Now what happens here is that once you change here, a traditionally closed system starts to break open. Okay? And then you have external markets coming in, then you have the concept of waste. Now, this is also known. Okay, I'm not telling you something new. This has been mentioned earlier also. But what we don't know is what happens to the environmental toxicity and stuff like that if you look at a life cycle assessment. And what happens is that with just the house changing from traditional building material to modern building material, there's minimum of 6 tons of carbon dioxide emissions contributed. Now, I'm saying this is without the geometry of the house changing. Okay? And if you then look at people's aspirations, so what happens here is that their aspirations to adopt modern building materials is higher. Okay, and if you go to the villages now, you have most of the youth working in urban areas. The farming is sort of breaking down, and you have money going back from urban areas to rural areas, and everyone wants to have a modern house. And what we found is that this initiator of change in the house, you know what is that? A function in the house. Somebody is getting married, there's some engagement, and immediately they change. That's when they pool all the money and resources. Okay. The problem is that if you're looking at these transitions and you project what happens in the future, the projection is that there's a this change alone can offset between 5 to 10% of the projected carbon dioxide emissions. Okay. And when I looked at efficiency, this is the okay, there are 2 energies. This is what I call embodied energy. How many of you are familiar with embodied energy? Okay, embodied energy is the energy going into making something. Okay, and then you have operational energy like operating your air conditions and stuff like that. So this is embodied energy. And this is the energy that their lifestyle is likely to take. Okay, so they give up firewood and they go for gas or maybe an induction cooker. Okay, but I'm not accounting for the rebound effect. And if you look at Europe today, if you look at Germany, you look at Sweden, all of them are today talking of the rebound effect. And do you know what the rebound effect is? Rebound effect states that with increasing energy efficiency, your net energy consumption goes up. So if you look at any Government of India documents, there will be an asterisk there saying we have not accounted for the rebound effect. What it means that we are probably owning more than a single mobile phone, we have probably more than 2 TVs at home, each of us probably owns more than 2 cars in the family. These are all energy efficient cars, these are all energy efficient appliances. So what happens is that with your appliances becoming more and more energy efficient, they become more and more affordable, their energy payback period is shorter, so people buy more of them, whereby your net energy consumption actually goes up. Okay. So if you start looking at houses and look at embodied energy and operational energy, like I said, embodied energy and energy going into the making of the building material, operational energy is to operate it. So traditional houses, your embodied energy is less than 2 gigajoules per meter square of the house, and operational energy is less than 1 gigajoules. Okay. Now if you start going up here, if you start looking at a lower middle income urban Indian household, this goes from 1 to 15. And I can tell you that this building right now is close to 30 to 42. You can measure it and then tell me if I'm wrong. Okay, I'm not saying you should not leave the buildings and go back to the villages, I'm just giving you information. Okay. And I was in China last year a couple of times. This is happening in China as well. You have earthen structures giving way to modern structures. Okay, and you already know Delhi is polluted now. China has always been polluted. Okay, in terms of air. And this is not only here. This is the University of Auckland, where this is a traditional construction in New Zealand, and this is their business school. And here again, this was in 2009 when I was there. Again, the architecture department was saying, you not considered dust, you built in glass, glass is not good, and stuff like that. Okay. This is one thing. Now coming back to this, okay, I'll quickly sum up. I'm not going to take these slides. But if you look at photovoltaics, when you put up photovoltaics, you can't have anything green there. You can't have trees casting a shadow on it. You can't have dust. If you see this is the Mojave Desert, and this is a truck there. The forests are cleared, and we call it green or sustainable or energy efficient or clean energy and stuff like that. Okay? And the other problem is that you know what this truck does every day? And you know what is the amount of water? Do you use salt water to clean or clean water to clean?
Do they not use compressed air?
No, it doesn't work. Compressed air doesn't work. Jets of air doesn't work. It doesn't work on a laptop screen. You try blowing air out of the screen. It doesn't work. Okay? This is the problem, dust. And dust, depending upon how much, can either take off 20% to 80% of the so-called energy that you're likely to generate. Okay? So this is something else we tried to test, but okay, I'll tell you this part. Okay, see, this is the IV curve. That means that when you have a photovoltaic, you try to get the voltage and the current that you get from it. Okay, so this is the current. Voltage doesn't get affected much from a panel. So a dusty panel, the output starts to go down. Then you have to clean it, and the amount of water that you use is nearly half a liter of water every meter square every day, and that's clean water. Okay, and this estimate we have verified it with the 2 or 3 megawatt level solar power plants, and everyone says ki all the water goes to the ground, that's groundwater recharge, so we don't worry about it. But I must tell you that's clean water, and we are fighting over Kaveri and the other parts, but half a liter of water is a lot per meter square. Okay.
Why don't they use salt water?
See, the problem with salt water is salt, and the cells are operating at 50 degrees, 60 degrees Celsius. Use salt water, you had it. The systems are going to corrode, electrodes are going to corrode, and you can't clean it. Okay? So it has to be ideally deionized water, which is without any salt, but TK, Bangalore water is alright. Now we got into another study to look at, okay, dust clean kare ya nahi kare. Okay, and the idea here was that if you look at photovoltaic systems, photovoltaic silicon based, like you said, inorganic, it actually works on the visual part of the spectrum. Okay, but you have UV and you have IR, right? And what IR does is it heats up the system, and not many of us know that when the system heats up, the output goes down. Okay, because it's supposed to operate at 25 degrees, that's the standard condition. Bangalore, if you measure cell temperatures, they go up to 60 degrees, 80 degrees. Okay, so what we found is that certain types of dust actually absorb IR. So it is a good idea to maybe allow a little dust to collect before you start cleaning them. Okay, so what we studied is that you can use a broom to clean your panels rather than use water every time. So that you know, there's a little bit of help, but this cannot be generalized everywhere because dust is not same everywhere. Okay, certain types of dust are able to absorb IR, but we can't say that for everything. Okay. So the problem with all this is that you have PV, then dust, and then temperature, and then wiring, and then all your laptops are DC, right? Am I right? But the photovoltaic electricity you get is DC. And not only that, you're storing it in the battery and stuff like that. So I'm going to cover this first. Again, yeah, this is something that you have to look at it from the sustainability point of view. If you look at the world malnourishment map, India is on it. All the solar rich regions are malnourished except Australia and New Zealand. But why does it? Actually, solar rich regions have a higher potential to grow crops, right? Why should they be malnourished? Sorry?
Through the year.
So, yeah. And this is one example of a design. This we were called in for the tsunami response that happened unfortunately in a place called Kodayampalayam. And this is the typical, so we were called in to provide housing and sanitation. I will talk about the sanitation part. And I'll close with this. What I was told is this is a very sparse population. There are just 300 families on that island. And people came to us and said, give us sanitation. And we originally told them that leave them alone. Okay, they are all going in the open. 300 families on a big island is not a problem. You have men who go fishing, they go to the boats. You can't expect them to come home and use the toilet. And the seawater is not a big problem because your the pathogens in your excreta don't survive on seawater. So there's no big deal. So you only talk of women and children. The women like to go in groups chit-chatting in the morning. So we said, okay, leave them. But then they said, no, that's not development. You have to give them something. I said, okay. And then the island has some cotton growing there. There is good drinking water at 4 feet level. Okay, good drinking water. They use firewood for cooking. So as designer, when I give you these requirements, what type of sanitation do you think you can provide them? They're generating some ash every day. They're having some agriculture on the island, and they have a very high water table. So generally, eco-san is what we call. It's a dry composting thing. It doesn't, you have to add ash every time you use it. Ash is anyway generated. It composts. When it composts, it's like natural soil. You can use that as a fertilizer for your crops. But then when we proposed that to the island, this guy said no. We want something where we can flush the system, and they already have some houses in the mainland. Many of them have, been to Singapore, Malaysia, and all that. But the thing is that when they come to the island, they prefer to squat in the open. So you can't do anything about awareness. Okay. So then we came up with this design called a modified compact septic tank, and we built in some features. This is the one we built 140 of these. And we did a couple of things. We said that it's a modified septic tank, as in instead of the same linear thing, we turned it around. We had a post filtration chamber whereby you can treat the water leaving the septic tank. And the feature that we have built into this is that if the entire toilet gets flooded and the water recedes, the toilets will resume functionality. That doesn't happen in the current toilets because they get flooded. Unless you take them off, take the waste off, you can't use them. And I mean, we built them in 2008, so no complaints yet. And what we also did is that instead of the wastewater leaving, we looked at the evaporative rate at those locations. And we said, okay, we'll dissipate the water very close to the surface. We created an impervious layer below so that that wastewater doesn't go and contaminate the groundwater. And what the community does is that they build a kitchen garden, so all the nutrient grows there, and then you're done. But again here, okay, this is not built by us, this was built by UNICEF. And I'm telling you, I'm talking about community attitude, and my doctoral work actually connected attitude to sustainability. Okay, and that's where it is. So UNICEF immediately came and built toilets for the women. The men was on the other side. And they had a hand pump here, so you had to go hand pump, take a bucket of water, go use the toilet. But the thing is that nobody used these toilets, and they preferred to use the space in between the toilets. Okay, and many of the places that we surveyed, the toilets either were pilfered or they were used to store firewood, because they said that it's a good, beautiful, watertight space. Why would I use it as a toilet? And even I would say a few of our toilets got converted into a kitchen or a storage room. That's it. Now, so as designers, if you want to design a place to store a firewood, you design it like a toilet. Okay. Okay. So, okay, this is the other part, but I'll close. If there are any questions, I'll take, but there are some other things I wanted to see. This is in China, this is still happening. This is in Seoul, South Korea, where unless you know Korean, you can't handle that thing, you can't even flush it. Okay. And this is something that I wanted to talk to you about, is the island. Okay. Like I said, the island village had good drinking water at 4 feet level. Then there's a community, that the NGO which came in and said, no, you should not drink water from the ground. We will give you a RO plant. Now, how many of you know how RO works? Sorry?
Pushing through.
Yeah, but how many of you have seen an RO system?
For each liter of water, waste.
Yes. Okay. So that many people don't know, and Bangalore does not need RO at all, because you're talking of ppm TDS value of 50 to 100. So what happens is that all the salt gets pushed into a reject water, and for every liter of water there's close to 2 to 3 liters of reject water that gets wasted. So this community came, they put a RO plant right in the middle of the island, and that's the wastewater reject plant that goes into the groundwater. Now the community does not have drinking water, they don't have electricity to run the RO plant which the government gave free at one time, and they can't go back to groundwater because it's completely saline. Now what do we look at sustainability here? Should we have just left them alone? I'm done. Okay. Should we have just left them alone, or we say, you know, this is technology advanced best and we go and intervene out there? I don't know. Okay, so now this is the last part with photovoltaics. Like I said, this is not my study though. This is a study on the life cycle assessment of the built environment, which says that if you look at the embodied energy, the energy going into making the solar cell, our study shows that if you operate the cells in perfect conditions, clean, expose them, your energy payback period is anywhere from 6 to 8 years. That means that it has to generate the energy for 6 to 8 years to be equal to the energy that has gone into its own production. And then you are energy positive. Whereas this guy is projecting 20 years. Your life of your panel is supposed to be 25 years. Okay? And I'm also part of this Indo-US group called SIRIUS. That's the Solar Energy Research Institute between the India and the US, working on a lot of things. I'm working on the part dealing with soiling studies and mitigation. And there is a study in Arizona by the Arizona State University where they are studying the degradation rate of the panels of all possible manufacturers in the world. That is, your panels are not performing in the same way for 25 years. They are degrading anywhere from 0.5% to 6% every year, either because of water getting in, or the polymer discoloring, or the cells cracking and stuff like that. So when you're looking at sustainability, what are we looking at now? Okay, so I will stop with this.